You might, I mean, everybody understands compound, I think, right?
I think so. Are we waiting on the
No, it's good. It's up.
Okay, so, and again, compounding is just where they calculate your interest and add that to your account so that it becomes part of your money. Fun and cheesy.
Yes, please.
Okay, now on the graph here, which two can I immediately rule out on my graph?
The one's going down.
The one's going down, right?
A and D.
If I'm earning interest, my money should be increasing,
Right.
not decreasing. So I can rule out A and D. That leaves me with B and C. So that's nice when I can rule out two of them. So I just need to graph this. So my equation was 4,000 e to the 0.09t. So I would do 4,000 times. And then you can click the E over here. Or if you just type E on the keyboard, it'll understand that. Then raised to the parentheses. Mine was 0.09. And then put your x instead of your t. Okay, now let's look at what we need our window to be. It looks like my x, they want going from 0 to 15, and then my y, they want going from 0 to 34,000. So make your window match their window. X is 0 to 15, y is 0 to 34,000. Okay, mine looks like that.
So how are you writing out the compound interest in your equation?
Am I putting it in?
Oh, E, duh.
Yeah, just type. You just do. It's got the E over there on the.
It's
thing.
times
The
E.
E on the keyboard, yeah. Yeah, you gotta put that 4,000 times.
Have you typed in the equation just in case?
Yeah, I'm trying to get this right. The C button over here. Looks like it goes about halfway up at the end, so I would probably put B there. And again, the main thing there is to tell it to multiply those first two numbers because it doesn't necessarily understand that. And then always put your entire power in parentheses. That's the most important thing. Always put the entire power in parentheses. Okay, now, this is something we haven't done before. It says use the graph to estimate when the future value will be $8,000. So it's asking when will my $4,000 grow to $8,000?
You can do a y-intercept.
Yeah, there's actually a couple different ways I can do this. One way I can do this is just to kind of scroll through my table until I see 8,000. Okay, so it looks like $8,000. I would go for 8,000 between 7 and 8 years. So I know my answer is going to be between 7 and 8 years. If I want to find the exact number, I can set y2 equal 8,000 and then find the intersection. So if you want to know when your money will reach a certain amount, then you can just find where would the line intersect that amount. If I want to do 8,000, okay, again, that looks like between 7 and 8 years. The exact number will be 7.7016 years. Is everybody following me here? Now there's a lot of questions like this where it says like when will your amount equal such and such. You just want to figure out when will your function intersect that. fixed amount. Okay, now it wants me to fill in my table. What is this asking for here?
It's
The same
asking
thing the one before it is asking.
when
The same thing the one before. It's asking what x value would make my y value equal that number. Now, the way I want to do that is I probably just want to look at my table and see if that number pops up in my table.
couldn't you just simply line intercept it?
Yeah.
Yeah, I could make my second equation equal to that number. Probably I'm just gonna see it in my table. It's like mine shows up at 14 here. So that should be one of the exact numbers in your table. If you just change your table start, just make that higher if you need to look at higher numbers. Mine looks like 14. Okay. Yes.
Sorry, mine's all on the y values at 12,000.
Click on the line for y1, the equation again, and highlight that white.
Okay.
It'll use that equation for the table. It uses whichever one you have highlighted. So like if I do this, it'll change it all to 8,000.
Okay.
You gotta highlight that white one. Which one? Which one? You're doing the really.
I always think it's the rounding one. I really see that's the really bad thing.
And then the last part for 10 and 20, you just want to read those values when x is 10. Or I can plug those in my calculator if you're having trouble with the rounding. Remember, sometimes the table rounds a little bit funny. It shouldn't, but it does. You can just plug those in the calculator to get the exact number.
About 18. How do we get this one?
Did you guys get 17? Alright, let's look at 18 and then we'll move on here. 18 is funny just because the numbers are funny. 18 is a radioactive decay problem, and you'll see a few of these. Usually since radioactive decay happens very, very slowly, usually the powers just include very, very small decimals. So here my function is A of t. A of t just means we are not remaining. 300 e to the negative 0.028333t. So for how many grams remain after 20 years? For A, I just want to plug in 20 for t. So the way I would do that in my calculator, I would do 300 times e raised to the power of negative 0.02833 times 20. Okay, and again, you just want to put those powers in parentheses.
Okay. Open it and take that.
You should get a positive answer. Your amount should always stay positive. Up here he's got multiply. You gotta multiply the power first, and then do e to the x, and then multiply by 6 squared.
In 45 years, you should know that over here.
You put in this negative, put in that decimal first.
Oh,
Negative 48.
and you need this
over
one.
2827.
Is that the 45?
Then times by 20
Here it is,
or 10
yeah.
or something.
28773. That's 3 decimal places. And there were 5. That's not right.
And then do the decimal then. And then times 20.
Go ahead. Is that what you said?
2 decimal places.
I wonder if this is an accurate equation. Hey, Tim.
And then 0.24 and now it's like 1.30.
Does it only say 0.33?
Okay, now if I want to graph that, I'm going to do it the same way I did before. So 300 times e to the power of parentheses negative 0.028. This is my decimal. 2833x.
So why are you using e in this equation?
It is.
Because I know we use it with the compound interest, but why with this?
It happens a lot in natural applications. It's used a lot. Sorry, I don't have a better explanation.
So basically, is it always going to give me the equation right there? Or am I going to? Okay.
We'll give you the equation. You can figure out the equation if they give you certain information, but this book doesn't go into that much depth.
Okay.
I think if they tell you the factor, like it occurs so much % per year, you can figure out the equation. But they just give you the equation. Okay, now I also on the graph I need to make my window range match their window. So x I want to go from 0 to 100, and y I want to go from 0 to 900. I'm just looking at what they have labeled on their axes there. So x went from 0 to 100, and y went from 0 to 900. That should make my graph look like theirs. It's like ticks every 100 units here.
Yeah, that's what I mean.
Now, once I get that graph, part C asks me about the half-life. Now, if you guys remember from chemistry class, the half-life is the time it takes for half your original amount to remain. That's also used in medicine a lot. They talk about the half-life of medication. That's half the takes half the original amount to remain, or for half of it to be decayed. Now, how would I estimate the half-life?
We divide, let's see.
Well, in order to figure out half the original amount, I need to look at what my original amount is.
So half the original amount would be 150.
My original amount, or initial amount, is 300. So half of that would be 150. So what I want to do is I want to say, where would this graph intersect half the original amount? So half my original amount is 150. Yours may be different if your original amount is different. Okay? So my amount starts at 300, goes down to 150 right here. I just need to figure out how many years that is. My years is my x value.
Pleasure.
So it looks like maybe 20-something years. 16, 17, 18, 19, 20, 21, 22, 23, 24. About 25 years here.
Did you put it in white too?
That's what I did. I'm just guessing here. It should be about 25.
Now, what's the green line?
The green line is half my original amount. So what was your original amount? Yours is 300. Oh, yours is the same as mine. So if you start with 300, then half would be 150. So I put in 150 for my green line. Okay, so it looks like about 25 years. That would be A. If I want to find the actual amount, I can just do the intersection. And that should be 24.47.
So why not just simply find the actual amount always, instead of guessing?
What do you mean?
I mean, we look at the graph and we know it's supposed to be around 24. Why not just simply intercept it immediately and find out what it exactly is 24.4?
I don't know.
No, just
no reason.
just for giggles. Okay. I was wondering if there's like a specific reason for an updated
No, I really
question.
didn't need to do that. I was just talking.
Okay.
Just talking to myself here, entertaining myself.
I do it all the time. No.
Now, that will be in your notes, right? Okay.
Yep, right here. What number was this? Was this 17? Here where we get the
Or 18.
16,000.
It was 18.
Where I have the P, RT. No, not the one we just did. I mean, where I have the 16,000 times 5 raised to the negative 408.
It'd be like.
What do you think? What do you think I was doing?
Sitting there joking about now.
I'm not doing that.
It was 15, I think, when you're 16,000.
Yeah.
I was like, oh.
I got my slides are out of order here. I'm trying to get them back in order. We actually need to move on here. Do you guys have any other problems you want to look at?
I do.
Number 9. Number 9, please.
All right, Ashley, what were you going to ask?
Number 21.
Number 21. All right, we'll do 9 and then 21. Okay, 9 and 21, they just want me to fill in this table. For f of x.
It's the g of x that I can't get.
All right, g of x is the problem.
I don't need 21 anymore, thank you.
You got it?
Yeah.
Okay, negative 2 to the negative x.
Then your x they give you is a negative number.
No, there's a negative 1 in front of that x.
Actually, the negative is not raised to a power. The negative is just stuck out in front. So whatever your answer is, you just make it negative. You see what I mean there?
Okay, so I would plug,
So,
so it would be negative
negative
2 to the negative second power, and then whatever my answer is, I would just make it negative.
Well, hold on. X is negative. So first you make your x negative. Because it's negative x.
So
Power.
so negative 2x is a positive 2x, right?
Hold on, let me make this thing right, and then we'll.
Because I'm not entirely sure what you're trying to say there.
Well, I'm trying to say I can't get it to right, so I can't write it down. This thing hates me. Like every computer, well, really every computer on my computer hates me. All right, I'm writing here. I want to click. Go here. I want to write. Come on, let me write.
Do you have to save that first?
No, it should be okay. Okay, there's. Let me write on the graph. Let me write on the homework. There we go. Okay, so x and then negative 2 to the negative x.
How did you get the fx?
The f of x, we did that at the beginning of class. That was the same function. I might have just used it. What's wrong, Todd? What'd you say?
I was just it's not relevant.
So you were talking about me or the class or something?
No. I was saying that the Spice Girls come out with the album.
Is that what he said, Alice? For real? You hope the Spice Girls come out with a new album?
You seriously don't like them?
No, I seriously don't like the Spice Girls. Actually, I haven't thought about the Spice Girls probably in about maybe 10 years or something.
For some reason when I'm doing exponential functions, they just pop into my mind.
That's the most I can do.
Yeah.
Spice up your life. I miss them
Spice
too,
up
you
your
know.
life.
No, I haven't
Wonder if those are both.
really contemplated the Spice Girls coming out with an album.
It looks like you.
Alright, what are we doing? What am I doing? Where am I?
You're trying to
Alright, negative 2 raised to the negative, and then x is negative 2. Okay? So negative 2 raised to the power of negative 2. Now what is negative 2? Negative x.
Positive.
If x is negative 2, then negative x is positive x.
That's what I asked earlier.
Yeah. When I was trying to get it right.
Yeah.
Okay, now what's negative 2 to the positive 2 power?
Well, that'd be positive 4.
Well, negative 2 is not raised to the power.
Negative
Oh,
4.
it's just 2.
Only 2 is raised to the power.
So it'd be a negative
The fact
4.
that the negative 2 is not in parentheses means only the 2 is raised to the power, and then whatever the answer is, you make it negative. So the answer is negative 4.
Ah. Okay.
Okay? If you wanted the answer to be positive 4, you'd have to have negative 2 in parentheses, then raised to the second power.
That's tricky. So now let's do 1.
Now negative 2 to the negative 1 power is the same as negative 2 to the positive 1 power,
Which is
negative 2.
Yeah. 0 is 1.
These are going to be negative numbers, right? The G is?
Not all, yes.
Okay.
Yes, they're all going to be negative. Because whatever your answer is, you make it negative. Because that negative in front means they're all going to be negative.
Now 0 is...
The negative x is going to turn your negative exponent positive, and your positive exponent will turn negative.
0 is going to be...
Okay, so what's negative 2 to the negative 0 power? Negative 2 to the negative 0 is still 0. Okay? Negative 0, 0, same thing. Okay? 2 to the 0 is 1, and then you make it negative 1.
Why? Is it negative 1 because the 2 itself is negative?
The power does not apply to the negative here.
Oh, duh,
The
again.
power only applies to the 2. The
That's right, 'cause
negative in
they're
front
not
just
in
makes the
parentheses.
result negative. Okay?
I keep forgetting they're not in parentheses.
Right, they're not in parentheses, so the negative is not raised to the power. Okay, and then I've got negative 2 to the negative 1 power.
Oh my God.
What's negative 2 to the negative 1 power? First of all, just ignore the negative in front. What's 2 to the negative 1 power?
That'll be 1.
1 half, then put the negative in front.
So negative 1.
Negative 1 half.
You need practice on these.
Yeah, you definitely need to Okay, what about negative 2 to the negative 2 power?
Is that negative 1/16? 1/4.
1/4. 2 to the negative 2 is 1/4. And the negative in front just makes it negative.
If I do that in the calculator, will it work it out for me?
So I'm getting all the answers right except for the first one.
Okay, you've got negative 2, and then the power is negative negative 2.
Yeah.
Well, negative negative 2 is positive 2. Okay? So you've got negative 2 raised to the positive 2 power. 2 to the second power is 4.
No idea.
It's not negative 2 raised to the power. It's the negative of 2 raised to the second power. 2 raised to the second power is 4, and then you make the answer negative. Yours would be 9. These should all be negative. Because you've got the negative in front, it's going to make all your answers negative.
No, it doesn't help.
You guys see the pattern between A and B here? They're backwards, and the second ones are all negative. So what's happening there between F and G, between x and negative x gives you the reciprocal. So the second set is just the reciprocal of the first set. So the negative x makes your number the reciprocal, and then the negative in front of g of x just makes all your answers negative. Okay, so changing the power from positive to negative just flips your numbers into the reciprocal, and then the negative in front makes your answers negative.
Okay.
I plugged in 0 and I didn't get the negative 1.
So I would put that in as negative 2 is the power of negative 0.
No, I'm doing okay. Thank you. Yep.
Alright, any other questions for Stefan? What is the asymptote of F and G?